Hello everybody, welcome to your first pre-recorded lecture of class 12 physics. As we have discussed in the live class earlier, today we want to carry out the derivation for the expression for the refraction at a spherical surface. So we are assuming over here that this is a medium with a refractive index n1, in which you have a second medium with refractive index n2. This is a convex spherical surface with center of curvature at C and radius of curvature R. Now, for this convex spherical surface placed in this medium with refractive index n1 and having a refractive index n2, we are assuming that n2 is greater than n1. So this is something like, this is plane air in which some kind of a cylindrical structure with a curved surface made up of glass or something like that. That is what we have kept. Now, suppose you have a small tiny object placed over here, and this is a principal axis for this particular curved surface. We'll name this curved surface as Mn. M and N are 2 points on the curved surface. M is on the principal axis. Object is placed on the principal axis. This is passing, principal axis has to pass through the center of curvature, so it is passing through C as well. Now, as we have always said, for all our derivations in this chapter, we are going to consider what are called as paraxial rays, which means rays which are going very close to the principal axis, almost parallel to the principal axis. And so all these angles, let us mark these angles, all these angles are very small angles. So that is an important assumption that we are making. Now, we know that any ray that goes along the principal axis will not go with any refraction, it will not undergo any deviation, it will go straight. So suppose one ray goes straight like this, and the second ray goes along this path, undergoes a refraction. Instead of continuing like this, it bends inward because this is a denser medium, so it has to come toward the normal, and accordingly it gets refracted and ends up coming here. Then, because this ray and a ray along the principal axis are meeting over here, we can assume that the image will be formed over here. So, object is placed at O, image is formed at I, and object distance will be from this point M to O. We are now assuming that this is a negligible distance. So this perpendicular NN, actually M is on the surface and perpendicular would be a little inside, but because this is a paraxial ray, so for all practical purposes, although in the diagram this looks big, ये actually बहुत छोटा है, and so for very small distances this is as good as being identical or coinciding, and so these we will not bother about that small distance. That is one more assumption, that is an approximation that we are making while going ahead with this. Now, let me say one point over here. When we make all these different approximations and assumptions, we are doing this in order to make our mathematics and geometry a little easier. But in real life, there will be a little distance. But for all practical purposes, for small angles and for small or paraxial rays, this is so small a difference that it does not really make any difference in actual practical life also. And so our assumptions we find are quite valid for paraxial rays. However, if you talk of a ray going very far away then this will not be a correct and valid assumption, and so your image will not form exactly like this as a sharp one point image, but it will be a little blurred image in in a wider area. So that part we are neglecting at the moment. We are assuming sharp image for paraxial rays. Now, having said that, let us see what is going to happen when a ray goes like this, casts an image like this, what relationship, what mathematical relationship we can have to connect object distance, image distance and radius of curvature for these two media with refractive indices n1 and n2. इन physical quantities को connect करने वाला equation क्या है? That is what we want to derive. To begin with, मैं ये relationship जो है, I am writing it on the board beforehand. So we want to derive this particular important relationship which says N2 upon V, which means refractive index of the medium in which the image is formed, N2 upon image distance minus N1 upon U, which means refractive index of the medium in which the object is kept upon object distance. So V image distance है, U object distance है, and N2 इमेज जहां फॉर्म हो रहा है वहां का रिफ्रैक्टिव इंडेक्स है, N1 ऑब्जेक्ट जहां रखा है वहां का रिफ्रैक्टिव इंडेक्स है. सो N2 अपॉन V, N2 अपॉन V minus N1 upon U, N1 upon U is equal to N2 minus N1, दोनों मीडियम के रिफ्रैक्टिव इंडेक्स का डिफरेंस N2 minus N1, and here as we have said we are assuming N2 greater than N1, so N2 minus N1 upon the radius of curvature R, N2 minus N1 upon R. This is an important relationship which helps us to find the relation between object distance, image distance for a spherical surface with refractive indices N1 and N2 and radius of curvature R. इन सबको connect करने वाला ये important relationship है. This is what we are trying to derive now. Now, let us take this figure and let us apply some geometry and some little bit of trigonometry knowledge and try to see how we get this particular derivation. As we go ahead with this, I will be going ahead with a discussion about all these steps. At any point you find कि ये step क्यों आया, ये नहीं समझा है, तो you please make a note of the timing and of that step, and then we will at some point when we have the live class you can discuss this and ask me कि sir ये step कैसे आया, please explain. Now, before I go ahead with the explanation of this, I will take a small pause. मैं एक 5 मिनट के लिए रुकूंगा. जो भी यहाँ लिखा है आप लोग भी अपने नोटबुक में इसको लिखते जाइए. दिस इज लाइक दिस. सो यहाँ से यहाँ तक और फिर यहाँ से यहाँ तक. सिंस आई हैव स्मॉल स्पेस आई हैव टू राइट इन लिटिल बिट ऑफ अ zigzag manner. तो ये डायग्राम बिल्कुल टेक्स्ट बुक वाला डायग्राम है, कोई चेंज नहीं है. मेन स्टेप्स भी ऑलमोस्ट एग्जैक्टली टेक्स्ट बुक के जैसे है. सो एट एनी पॉइंट यू मे रेफर टू द टेक्स्ट बुक ऑल्सो. थोड़ा मैंने स्टेप्स को रीअरेंज किया है टू मेक इट इजियर टू अंडरस्टैंड एंड आई हैव गॉट दिस रिटन आउट. आप लोग इसको पहले अपने नोटबुक में लिख लो सो दैट एज आई डिस्कस you will also be able to note it and make suitable, or you will be able to follow it better in your notebook. And also if there are any doubts, make a small question mark over there so that you can ask the doubt afterwards. So मैं यहाँ थोड़ा सा pause ले रहा हूँ एक 4-5 मिनट का. तब तक आप इसको यहाँ से ऐसे ऐसे ये this part and then this part up to this end result, इसको आप प्लीज लिख लीजिए. I hope you have completed writing this. As we go ahead with this, please feel free to give a feedback. If this size is too small to write and on small screen nahi dikh raha hai, you let me know. I will be able to make suitable changes when I go ahead for the next session. So as we go ahead, it is going to be learning experience for both of us. आपके लिए भी, मेरे लिए भी, how we go about planning all of this. So I need your feedback about this and don't feel free to give a negative feedback. कुछ अगर ठीक नहीं हो रहा है कि ये नहीं समझ में आ रहा है, ये बहुत स्लो जा रहा है, ये बहुत फास्ट जा रहा है, तो you feel free to send a WhatsApp message to me कि सर ये ऐसा ऐसा प्रॉब्लम है. Don't hesitate about this. Okay, now let's go ahead with a discussion about what we have written on the board and what you have also written in your notebooks. So इस figure को reference में लेते हुए, to quickly revise, this is a medium with refractive index n1. This is a curved spherical surface and having radius r and refractive index n2. This is its center of curvature. In medium n1, we have kept an object at O, from which a paraxial ray goes like this, O to n, ON, making an incidence angle of incidence I over here. Because this is a denser medium, instead of continuing like this, the ray bends towards the normal and comes somewhere here. Any ray going along the principal axis goes undeviated. So एक ray ऐसा, एक ray bend होके ऐसा, दोनों यहाँ पे intersect करेंगे. इसका मतलब है image will be formed over here. So for object at O, we have got image at I. M से लेकर O तक we measure from the pole, so this becomes object distance. M से लेकर I तक, this becomes image distance. So we have marked this U, we have marked this V. According to Cartesian sign convention, U will be negative क्योंकि ये हम negative direction में measure कर रहे हैं. V will be positive and R, radius of curvature, will also be positive. Now we want to derive, as we said, n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. इसको अब हम derive करना शुरू करते हैं. Now have a look at this triangle OMN, ये वाला triangle. OMN triangle में, let me take my marker please. Okay, OMN triangle में, if I look at angle NOM, this angle NOM, तो इसके लिए MN, this is opposite side, and MO, this is adjacent side. So tan of this angle NOM is equal to MN upon MO. That is what I have written over here. Tan angle NOM is equal to MN upon MO. Okay, so ये लिखा एक part. As I finish discussing something, I will start blocking it out so that you can keep focusing on what we are going ahead with. Then next, tan angle NCM, ये वाला angle, ये जो यहाँ दिख रहा है, tan angle NCM, this will be opposite side MN upon adjacent side MC. So ये MN upon MC, tan angle NCM is MN upon MC. And now we come to a third angle यहाँ पे. This is angle NIM. So tan of angle NIM is opposite side, which means again MN upon adjacent side MI. So this becomes MN upon MI. MN upon MI. Now, we have said that we are considering only paraxial rays over here, and for paraxial rays, we find that for very small angles, paraxial means these angles are going to be very small, these rays are going to be very close to the principal axis. In that case, for all small angles, tan theta is almost equal to, approximately equal to theta itself. So इसमें से हम tan वाला part eliminate कर सकते हैं, and we can say that approximately tan angle NOM की जगह we can just write angle NOM is equal to mn upon O. Same way, angle NCM is equal to mn upon MC, and instead of tan angle NIM, just write angle NIM is equal to mn upon MI. So because all these angles are very small, because all these are paraxial rays, so tan of an angle की जगह हम डायरेक्टली उसी एंगल को ले सकते हैं. अप्रोक्सीमेटली ये वैलिड है. So for all these three angles, we have now got angle NOM equal to mn upon MO, angle NCM equal to mn upon MC, and angle NIM equal to mn upon MI. So इसका रीजन यहाँ हमने दिया है, for small angles tan theta is approximately equal to theta itself. Now coming to the next step, if you see this angle I, then consider this triangle ONC, ये वाला triangle. इस triangle के लिए this is like an exterior angle. See, this is an extension, so this is angle I is an exterior angle, and exterior angle is equal to sum of the other two interior angles. So angle I is equal to angle NOM plus angle NCM. ये दो interior angles, इनका sum it will be equal to this one exterior angle, and so that is what we have written over here. Angle I is equal to angle NOM plus angle NCM. इसका रीजन क्या है? I is an exterior angle. Exterior angle at any given angle of a triangle is equal to sum of the other two interior angles. So इस basis पे हमको आ गया angle I is equal to angle NOM plus angle NCM. Similarly, if you consider this triangle, ये जो obtuse triangle दिख रहा है यहाँ पे, इसमें ये वाला एंगल NCM ये एक्सटीरियर एंगल है, और ये दो एंगल्स जो है एंगल R और एंगल NIN. सो ये वाला एक एंगल और ये वाला, ये दो इंटीरियर एंगल्स, और ये वाला exterior angle. Again, exterior angle is equal to sum of the other two interior angles. So we get this angle NCM. Angle NCM is equal to one interior angle, angle R, plus second interior angle, angle NIM. So we have got this relation, angle NCM equal to angle R plus angle NIM. इसको थोड़ा रीअरेंज करके हम लिखेंगे, therefore angle R is equal to NCM minus NIM. इसको लेफ्ट हैंड साइड को लिया, एंगल NCM minus NIM. सो इनको रीअरेंज कर लिया. अब इसको मैंने लेफ्ट हैंड साइड पर लिख लिया. वी आर इंटरेस्टेड इन समथिंग टू डू विथ एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्रैक्शन, बिकॉज स्नेल्स लॉ में हमारे पास sin I upon sin R होता है. सो I का एक टर्म लिया, R का एक टर्म लिया. We got I is equal to angle NOM plus angle NCM, and angle R is equal to angle NCM minus angle NIM. Now यहाँ पे हमने देखा है कि NOM is mn upon O, NCM is equal to mn upon MC, and we have also seen that NCM वापस एक बार यहाँ पे mn upon MC and NIM is mn upon MI. ये हमने यहाँ पे ऑलरेडी लिखा हुआ है, तो इसको सब्स्टिट्यूट करते जाएंगे. So NOM is mn upon O. So from this we got this substitution. Then NCM is this. So ये substitute होके यहाँ आ गया. ऐसे ही यहाँ पर भी हमको NCM की जगह mn upon MC and NIM की जगह mn upon MI. ये substitution यहाँ से यहाँ पे आ गए हैं. So we have got angle I is equal to mn upon MO plus mn upon MC, and angle R is equal to mn upon MC plus mn upon MI. ये आने के बाद अब हम Snell's law लेते हैं. Snell's law says sin I upon sin R is equal to n2 upon n1. This is what you have already studied earlier. Snell's law के हिसाब से the ratio of the angle of incidence to the angle of refraction is constant, and it is equal to the ratio of the second medium refractive index upon first medium refractive index. So यहाँ पे हमारा second medium n2 है, first medium का refractive index n1 है. So sin I upon sin R is n2 upon n1, which we can rearrange, cross multiply and write as n1 sin I is equal to n2 sin R. So n1 sin R equal to n2 sin R. And again parallel rays है, तो जैसे tan of an angle is almost equal to the angle, वैसे ही sin of the angle is also almost equal to the angle. For all small values, sin and tan will be very small. Cos will not be small. Cos 0 1 होता है, cos 90 0 होता है, लेकिन sin 0 0 होता है, tan 0 भी 0 होता है. तो एंगल 0 से थोड़ा बढ़ता है, तो sin वैल्यू थोड़ी सी बढ़ती है, tan वैल्यू भी थोड़ी सी ही बढ़ती है. And so for all practical purposes, for small angles, sin theta is almost equal to theta, and so we can write, instead of sin I, just I once again. So n1 sin I equal to n2 sin R now becomes n1 I is equal to n2 R. यहाँ तक I hope you have understood. किसी भी पॉइंट को यहाँ तक नहीं समझा है तो आपने जहां ये लिखा हुआ है वहां पे एक छोटा सा क्वेश्चन मार्क लिखो, एंड हम इसको डिस्कस जरूर करेंगे क्यों ये स्टेप आ गई है. ओके, नाउ वी हैव गॉट I equal to mn upon mo plus mn upon mc, and we have got r equal to mn upon mc minus mn upon mi. तो ये दो सब्स्टिट्यूशंस जो है, I की जगह ये और r की जगह ये हम यहाँ सब्स्टिट्यूट कर सकते हैं. So n1I is equal to n2R becomes n1 into bracket I equal to mn upon mo plus mn upon mc, ये यहाँ लाया. So ये I की जगह ये सब्स्टिट्यूट किया, R equal to mn upon mc minus mn upon mi, ये यहाँ लाया. And so we have got this as n1 into mn upon mo plus mn upon mc equal to n2 into mn upon mc minus mn upon mi. I hope you have understood again up to this point. अब यहाँ से हम यहाँ आ जाते हैं. यहाँ न्यूमरेटर में mn है, यहाँ भी है, यहाँ भी है, यहाँ भी है. So दोनों साइड पे हम mn को कॉमन निकाल के कैंसिल कर सकते हैं. We can get rid of the mn part over here, and so we have got mn out over here, mn out over here, and cancelled it. mn बाहर निकालने के बाद यहाँ 1 रह जाएगा, यहाँ भी 1 रह जाएगा, यहाँ भी 1 और यहाँ भी 1. So accordingly n1 into 1 upon mo plus mc, 1 upon mc, and n2 into mn cancelled and 1 upon mc minus 1 upon mi. ये ब्रैकेट ओपन करेंगे तो n1 दोनों का न्यूमरेटर बन जाएगा, यहाँ पे n2 दोनों का न्यूमरेटर बन जाएगा. एंड सो वी गेट दिस स्टेप n1 upon mo plus n1 upon mc is equal to n2 upon mc minus n2 upon mi. So this is what we have got over here. Now once we have got this, इसको थोड़ा सा रीअरेंज करेंगे. ये माइनस n2 अपॉन mi जो है, इसको इस साइड ले आएंगे तो पॉजिटिव हो जाएगा. एंड सो दिस विल बिकम, वी हैव टेकन दिस टर्म एंड ब्रॉट इट ओवर हियर, एंड वी हैव टेकन दिस टर्म एंड ब्रॉट इट ओवर हियर. ये यहाँ पॉजिटिव है, यहाँ आके नेगेटिव हो जाएगा, ये यहाँ नेगेटिव है, यहाँ आके पॉजिटिव हो जाएगा. एंड सो दिस विल गेट रीअरेंज्ड एज n1 अपॉन mo प्लस n2 अपॉन mi इज इक्वल टू n2 अपॉन mc माइनस, बिकॉज ये माइनस हो गया, n1 अपॉन mc. सो ये स्टेप इनको रीअरेंज करके हमारे पास आ गई है. अब ये mo, mi, mc वगैरह की भाषा हटा के instead we can put in terms of object distance, image distance and the radius of curvature, because mo is nothing else but object distance u, but because it is measured towards the negative axis, it is going to be minus u, and so we have got mo equal to minus u. Then next mi is image distance v, and because this you are measuring from the pole in the positive x-axis direction, so ये positive है, and ये radius of curvature भी आप positive direction में measure कर रहे हैं, तो ये भी plus है. So accordingly take these three substitutions and put them over here and we have got what we wanted. अच्छा ये दोनों का common denominator है MC इसको common लिया and MC equal to R तो ये common denominator R बन गया and यहाँ पे हमने image distance MI की जगह ये जो था अच्छा ये नेगेटिव हो गया है तो इसको थोड़ा रीअरेंज करके इस तरफ लिखा है. So this is, if you want, you can put one step in between, but not essential. So N2 upon V ये पॉजिटिव है और ये माइनस U होने वाला है. MO is minus U. So minus N1 upon U plus N2 upon V जिसको रीअरेंज करके हम लिखेंगे N2 upon V minus N1 upon U is equal to N2 minus N1 upon R. And that is the final result that we wanted and we have obtained this relationship. This is the discussion and explanation related to this particular derivation. अब जैसा मैंने बताया आपको ये लर्न करना है क्योंकि ये बहुत इंपॉर्टेंट डेरिवेशन है, अक्सर वेरी ऑफन पूछा जाता है. So board exams में about something like a 3-mark question, this is a very frequently asked thing and so you should know this. The relationship for refraction at a curved or a spherical surface, this is what we want over here. इसके कुछ variations भी आ सकते हैं जैसे instead of a convex surface what if this is a concave surface or if this is a denser medium and this is a rarer medium तो क्या होगा. तो ये जो variations है कभी rare case में CBSE board exam में टेक्स्ट बुक में दिया नहीं है but the essential logic remains the same. इसको instead of convex अगर concave हो गया तो क्या होगा, इसका rarer and denser न होते हुए denser and rarer हुआ तो क्या होगा. ऐसे अलग अलग cases बन सकते हैं और उसके basis पे कभी कभी very rarely CBSE बोर्ड में एक दो बार in the last 10-15 years इस टाइप का question आया है. तो ये अलग cases का हम एक आध लाइव सेशन में उसका एक आध डिस्कशन जरूर करेंगे. ये लेकिन कॉमन है, ये टेक्स्ट बुक में भी दिया हुआ है एंड दिस इज मोर फ्रीक्वेंटली रिक्वायर्ड. सो दिस इज समथिंग व्हिच यू शुड डेफिनेटली नो. सो दिस you must study well and prepare. The other ones are for a rare chance once in a while, which also we will do at a subsequent later date for revision and board related questions. जब हम डिस्कस करेंगे किसी लाइव सेशन में तब वो अलग थोड़े केसेस भी हम जरूर डिस्कस करेंगे. सो ये हो गया हमारा अपना ये एक डेरिवेशन. ये आपको लर्न करना है. दिस रिलेशनशिप शुड बी नाइसली फिटेड इन योर माइंड. इट इज वेरी लॉजिकल एंड इजी. सेकेंड मीडियम N2 यहाँ पे इमेज बना है सो N2 अपॉन V. फर्स्ट मीडियम N1 यहाँ पे ऑब्जेक्ट रखा है तो N1 अपॉन U. सो N2 अपॉन V माइनस N1 अपॉन U ये हो गया लेफ्ट हैंड साइड इज इक्वल टू N2 माइनस N1 अपॉन R. That's all. That is all that you have got over here. So learn this, keep it nicely memorized, and this point we will pause for this particular video. Thank you all. Please, as I said, feel free to give a feedback. You know I will never ever get angry even if you say कि sir क्या आपने पढ़ाया कुछ समझ में नहीं आया, पूरा सब वापस समझाओ, तो भी no problem. I will remake a video or I will conduct it in a live. I need to know कि आप लोगों को कहाँ पे कुछ मुश्किलें आ रही, कहाँ पे परेशानी आ रही है, क्या दिख रहा है, क्या नहीं दिख रहा है, क्या सुनाई दे रहा है, क्या नहीं सुनाई दे रहा है. Then I will be able to make suitable changes. So feel free to come back with your changes to me and I will make those changes. I am not going to say कि तो क्या मैं वापस करूँगा? Of course वापस करूँगा. If there is a problem, I will do it again. Don't at all hesitate to ask. That's a promise. Bye. See you.